sometimes in these problems, they'll give you the sequence written in one form, and then they're going to tell you to write it in the other form. And so like if you look, for instance, at this example down here, it's giving you the recursive form of the sequence, and then you have to write it in the explicit form. And so when you have to do that, no matter which form they give you, the first thing that you will always do is you are going to write the sequence out, okay? So you are going to use whatever form they give you to write the sequence out. So write the sequence out first. That's the thing you need to remember with those problems. Okay, so write the sequence out first. So make sure you get that down, okay? And that will save you a whole lot of time and frustration, okay? And so we're just going to work through a couple examples of how to do this, and then hopefully that'll help as you work without me, okay? So with number 5, it says, given the recursive form, so that's the recursive form, and we'll review that. You have to write the explicit form. So remember, recursive form is based on the previous term. So what it's telling you to do is, or it's going to tell you what to do to the previous term to get to the next term. And so that's what you need to remember. So remember, this would kind of be like your next term in your sequence. And then remember the a with a little subscript of an n minus 1, that's actually the term with the position right before that one. And so this would be kind of like your previous term. And so you have to remember that. Okay, so, well, what are you doing in this equation to your previous term to get the next term? And if you notice, it's taking the previous term and it's multiplying by 4. And so that's the pattern of your line, as you are multiplying by 4. And then this is the whole reason why they have to also give the a term in your sequence, is so you know where to start. So like we're told that the first term of my sequence is 5. And so, like I said, make sure you write the sequence out first. And so when I write the sequence out, I'm going to start with 5. That's my first term. And then I'm going to use what this tells me to write the rest of it out. And so it's telling me that I'm multiplying by 4. And so to go from this term to the next one, I would have to multiply by 4. So 5 times 4 gives me 20. And then you can write out however many terms you need so that you can do the next part. And so maybe I'll write out, I don't know, maybe 2 more terms. So to go to the next one, I continue that pattern. So 20 times 4 gives me 80. And then if I go again, 80 times 4 would give me 300. I don't think I made my space big enough. It'd give me 320. Okay, and then I could keep going, because like I said, you can write it out however far you need to be able to kind of see what's going on in the sequence to be able to write the other equation. Okay, so from there, you are going to look at how to write the explicit formula. So to write the explicit formula, that's what we talked about the other day, as to there's 2 ways to kind of think about it. You can think about, okay, explicit formula is based on the position of the term, so based on the position, which is your n in the equation. And so you could think to yourself, okay, what do I do to 1 to get 5? Whatever I do there has to be the same thing that I do to 2 to get 20, 3 to get 80, 4 to get 320. These are the positions of those terms. And so if you can reason that way, go for it, okay? If that doesn't work, then you look at what type of sequence it is. And so since you're multiplying, this would be a geometric sequence, and you use the explicit formula for that. So if you need to go back and grab your notes so you can look up those formulas, then do that. But the geometric formula for the explicit form of writing it would be a sub 1 times your common ratio, and then you take it to the power of n minus 1. So if you're just writing the equation here, you're just going to plug in, remember, this is the first term and then you're going to plug in your common ratio, and then you'll have your equation, because nothing will really simplify from there, okay? So to write my equation, and I'm actually going to just go ahead and write it up here since it won't simplify. Plug in your first term. So my first term was 5. So that's what goes there. And then you're going to be multiplying that times the common ratio, which is 4, however many times to get to the term. So it'd be to the n minus 1, okay? So that is the explicit form of that sequence, okay? So what if they reverse it on you? So like in the next problem, it says, given the explicit form, you have to write the recursive form, all right? Well, again, you've got to remember explicit, there's a reason why this looks different, because explicit is not based on the previous term, it's based on the position of it. So the thing you need to remember is that n right there is the position of the term, okay? So if you have to write this sequence out here, you're going to have to think about this equation a little different. This is the position of it. So like if I'm finding the first term, you plug in a 1 right here. So if I have to write out this sequence, I'm going to do kind of each term separately. It's not as easy as writing it out using recursive. So plug in a 1, so it'd be 3 times 1 minus 1. And then when I simplify that, I will have found my first term. So 3 times 1 is 3, and then 3 minus 1 is 2. So that's my first term in my sequence. So again, the first thing you do is write out the sequence. So to find the second term, I do the same thing, but now I'm finding the second term. So I'm going to put a 2 in there. So it'd be 3 times 2 minus 1. 3 times 2 is 6. 6 minus 1 is 5. So that would be the next term in my sequence. And then let's do at least one more. So the third term, I'd take the same equation and plug in a 3. So that would be 9 minus 1 is 8. Okay, and then if you needed to write more out, you can. You would just plug in a 4 and then a 5, however many terms you need to figure out what's going on. So now, the recursive form, you're going to look at this and you're going to find what the recursive form is. So remember, recursive, it's telling what to do to the previous term to get the next term. Okay, so what do I do to the previous term to get the next term? So you're looking at the pattern here. And then remember, there's 2 ways of writing it, okay? So let's find the pattern first. What am I doing from term to term? And you'll notice that I'm adding 3. And so that means it's an arithmetic sequence, okay? And there were 2 ways to write the recursive form, okay? One way that you could write it was the informal way. And I'm actually going to write my answers down here just because I didn't leave myself enough room. So the informal way was using the next now. And so to get to the next term, what am I doing to the term I have now? And so to get to the next term, like if I started at 2 and I had to get to the next one, what am I doing? Well, I would be taking the term I have now. I would be taking the term I have now and adding 3. So I take what I have now, I add 3 to get to the next term, okay? And then remember, the other thing you have to write is where it starts. Where does this sequence start? And so it starts at 2. So that's the informal way of writing it. The formal way would be using that notation that you saw up here, the one that had the a sub n and the a sub n minus 1. And so to find, oh, I didn't mean to put an equals right there. So to find the a sub n term, which is just a term in your sequence, you have to take something and do something to the term right before that one. So you take the previous term, and well, what are you doing? Well, we are adding 3. So you take the previous term and add 3 to get to the next term, okay? And then remember, you also have to tell a term in your sequence. So we usually tell the first term, which would be 2. So that would be the recursive form of that sequence.